Nuclear fusion. It is a process in which two lighter nuclei fuse together or combine together to form relatively bigger nucleus, and in the process amount of energy is released. That is what fusion, nuclear fusion. When two lighter nuclei combine together or fuse together and form a bigger nucleus, then an amount of energy is released. This process is known as nuclear fusion. There are different ways of nuclear fusion to take place, but important equations can be given like this. Two deuteron nuclei can be combined together, fused together to form a helium nucleus, and in the process an amount of energy is released. Q stands for amount of energy. And this is one process. You see, this is a deuteron nucleus. It's an isotope of hydrogen with mass number 2 and atomic number 1. Two such deuteron nuclei are combined together and the resultant is a helium nucleus, and a large amount of energy is also released in the process. That is nuclear fusion. In another mechanism, 4 protons may be combined together to form a helium nucleus, and in the process 2 positrons are also emitted, and with the release of an amount of energy. Here this is a proton. It's represented by hydrogen nucleus because hydrogen consists of only one proton. So such 4 protons are combined together to form a helium nucleus, and in that process 2 positrons are also emitted with a release of energy. This energy Q is equal to 26.7 million electron volts. That's the amount of energy released in a fusion process. Now when you look at that equation, it may appear to be a simple that 2 nuclei may combine together or fuse together, but in practice it is not that easy, because if you take a nucleus, basically it is a positively charged body, and consider another nucleus which is also a positively charged body. If both of them are moving together so that we are trying to fuse them together, in such case what will happen is, between 2 positively charged particles there exists a Coulombian repulsive force, and as they approach closer and closer, this repulsive force increases to a very large value. Therefore it is difficult and near impossible for 2 positive nuclei to fuse together. The only way to fuse these 2 nuclei together is, the kinetic energy of each nucleus should be so large that they overcome the Coulombian repulsive force between them. The kinetic energy of each of the nucleus should be so large that they are capable of overcoming the Coulombian repulsive force between them. In such case, both the nuclei can fuse together and fusion process can take place. But you see, if the kinetic energy of the nucleus to be so high, the temperature of the nucleus should also be very high. It is observed that the temperatures of the order of 10 power 7 Kelvin to 10 power 9 Kelvin, this is the order of temperature required for the nuclei to have, so that their energy becomes so high and they are capable of overcoming Coulombian repulsive force and fuse together. And such high temperatures are available in the sun and other stars. That is the reason why the source of energy for stars is fusion. In that, these 2 processes may take place, resulting in a release of energy, and that large amount of energy is radiated into the universe. That is what we are receiving as solar radiation also. So the source of energy for stars such as sun is nuclear fusion.